Today we're going to be multiplying and dividing rational expressions. So your essential question is, what is the difference between multiplying and dividing rational expressions? So I know that the difference is when you're multiplying and when you're dividing, but there's differences in the processes. So we're going to talk about those today more in depth. Okay, so first we are going to multiply these rational expressions together. So rational expressions generally means fractions. So when you think about it, if I was to multiply 3/5 times 1/2, what would be the process for multiplying these two fractions? Well, when I multiply fractions, I go straight across, so I would get 3/10, and then I would just see if I could reduce. So when you're multiplying fractions, you multiply straight across. Okay? Now, just like simplifying rational expressions, it's best to always factor before we multiply, because then we can see what cancels out since we're dealing with polynomials and not just numbers. So before we multiply straight across, because that would be a very long process, we're going to go ahead and factor and simplify this. So if I factor 3x squared minus 3x, what method would I use to factor that expression? Well, the first thing I always look for is greatest common factor. So I notice that the greatest common factor of this expression is 3x. And then if I divided that out, I would have left over x minus 1. Okay? Then, if I look at the bottom of this fraction, it's a trinomial, and there's not a number in front of x squared, so I'm going to find factors of -5 that add to be 4. So I would have x minus 5. So I'm trying to multiply, to be -5 and add to be 4. So I could use 5 and 1, and the 5 would have to be positive. So it'd be x plus 5 and x minus 1. Then, on the other fraction, this one is also a trinomial, so I'm looking for factors of -20 that add to be 1. And so I could use 1 and 20, I could use 10 and 2, or I could use 5 and 4. And 5 and 4 would be my match. And which one would have to be negative to make 1? Well, the 4. So it would be x plus 5 and x minus 4. Then 3x cannot be factored, so I would leave that the same. So the first thing I did was I factored everything. Okay, now I can go ahead and cancel things out first, or I can go ahead and multiply straight across first, however you would like to do that. So if I multiplied straight across first, I'm just going to keep everything in its factored form. I'm not actually going to multiply anything. So I'm going to have 3x, I'm going to have x minus 1, I'm going to have x plus 5, and I'm going to have x minus 4, all in the numerator. Because if I multiply it, I'm just putting them all together. Then on the bottom, I would have x plus 5, I would have x minus 1, and I would have 3x. And I usually like to put those in the front, because then it's easier to pick out. So from here, if I wanted to see what canceled out, then I would look and I could see that the 3x's canceled out, and I would also see that the x minus 1's cancels out, and I would also see that the x plus 5's cancel out. So the only thing that I'm left with is x minus 4, so that would be the final answer. So just to recap, you don't have to write these steps down, but if you'd like to, it might be helpful. First, you have to factor all the numerators and denominators. Then we multiply straight across, and then we cancel out common factors. All right. So let's say I'm just multiplying a rational expression, which is a fraction, with a polynomial. Okay? Well, when I'm multiplying fractions, I like to make sure that both of my things that I'm multiplying together are fractions. So the easiest way to do this would just be to turn this into a fraction by putting a 1 on the bottom. Okay, then we can follow the same exact steps that we did in the last example. Now remember, this right here is a difference of cubes. So when I factor it, I need to use my formula for the difference of cubes. Okay, so from here, x plus 2 cannot be factored. X cubed minus 27 is a difference of cubes. So if I take the cube root of both of these numbers, then a would equal x and b would equal 3. So I'm going to plug those into my formula. So I would have x minus 3, and then I would have a squared, so x squared, plus ab, and that would be 3 times x, which would be 3x, and then b squared, so 3 squared would be 9. So this is what I would get for my first one. Now the second one is already x squared plus 3x plus 9 over 1. And I could try to factor that, but if I try to factor it, I'm finding factors of 9 that add to be 3. And so my options would be 1 and 9, which add to be 10, or 3 and 3, which add to be 6. So this one would not be factorable. So if I go ahead and I multiply straight across, I would have x plus 2, and I would have x squared plus 3x plus 9. And then I would have x minus 3, and I would have x squared plus 3x plus 9. And then I multiply by 1, so really I can put the 1 here, but it doesn't really change anything. So if I cancel out my common factors, then this x squared plus 3x plus 9 would cancel out with the bottom one. And so therefore, we would just have x plus 2 over x minus 3. And that would be the final answer. So just to go back over that, first what we did was we rewrote the polynomial as a fraction. So we just put a 1 on the bottom. Okay. Then we factored the denominator. The top was not factorable on either side. And then we canceled out common factors. So it's very similar. The only thing we did different on this example was we changed the polynomial into a fraction by putting a 1 on the bottom. All right, now we have dividing rational expressions. So think about normal fractions. If I have 3 halves divided by 5/4. When I'm dividing normal fractions, what is the process for that? Well, instead of dividing, we would multiply by the reciprocal because that's easier. So I would have 3 halves times the reciprocal of 5/4, which would be 4/5. Then I would simply multiply straight across. So I would get 12 over 10. And then I would reduce. So if I divided these by 2, I would get 6/5. And that would be my final answer. So first you multiply by the reciprocal, and then you go straight across, and then you reduce. It's the same process with polynomial expressions. So instead of dividing, the very first thing we're going to do is we're going to multiply by the reciprocal. So the first one stays the same, and then we multiply by the reciprocal, which would be x squared minus 11x plus 30 over x squared minus 6x. Okay, so now it's back to a multiplication problem. So the difference between multiplying and dividing is that when you're dividing, you're actually multiplying by the reciprocal. So now from here, we would just factor and do it like we've been doing this. So I can't factor the 7x. Is there anything I could factor out of the 2x minus 10? That one has a greatest common factor. The greatest common factor would just be 2. So I would take out 2 and I would have left over x minus 5. Okay, then the top is a trinomial, so I'm looking for factors of 30 that add to be negative 11. So it'd be negative 6 and negative 5. Because negative 6 times negative 5 is positive 30, and they would add to be negative 11. On the bottom, I would take out the greatest common factor. So I would have x come out of this, and I would have left over x minus 6. Okay, so from here, if we go straight across, we would have 7x, we would have x minus 6, and x minus 5. And then on the bottom, we would have 2, and I like to put all the single things out front, so I'm going to also put the x out front. And then we have x minus 5 and x minus 6. Now, if that confuses you, you can just rewrite everything as it is, but it's just harder to look for later on. So from here, I'm going to cancel out anything I can. I'm going to cancel out these x's. I'm going to cancel out the x minus 6's. And I'm going to cancel out the x minus 5's. So really then, all that is left is 7 over 2. And that would be my answer, because that cannot be reduced. Okay, so to recap that, what I did was at first I changed to multiply by the reciprocal. Then we factored. And we multiplied straight across, and then we canceled out common factors. So it was the same steps as before. The only thing we added was that we multiplied by the reciprocal because it was a division problem. All right, one more example and then we're finished. Okay, this is the same thing. When I'm dividing an expression by a polynomial, it was kind of like the last one that I did. When I'm dividing fractions, it's easier if both of them are fractions. So all I'm going to do is just put a 1 on the bottom of this. Okay, then because I'm dividing, instead of dividing, it's easier if I multiply by the reciprocal. So I have 6x squared plus x minus 15 over 4x squared times, and I'm going to do the reciprocal of this, so it's going to be 1 over 3x squared plus 5x. So now I'm going to factor. So if I look at this top one, there's no greatest common factor, and it's a trinomial with a number in front of the x squared. So there's only one way to factor this, and that's the AC method. And I'm going to do this out to the side. So remember, with AC method, this is A, this is B, this is C. So I'm taking A times C. So I'm taking 6 times negative 15, which would be negative 90. So now I'm trying to find factors of negative 90 that add to be 1. So I could do 9 and 10, and the 9 would have to be negative. Now all this does is it just replaces that middle factor. So I have 6x squared minus 9x plus 10x minus 15. So now because it's got 4 parts, I have to factor by grouping. So then the greatest common factor of this first group would be 3x. And I would have left over 2x minus 3. And then the greatest common factor of this group would be 5. And so I would have left over 2x minus 3. So then they both have 2x minus 3 in common. So if I were to take that out, then I would have left over 3x plus 5. So if I wanted to check, I could distribute this out and I would end up with what I started with. So the top of this one factors into 2x minus 3 times 3x plus 5. The bottom cannot be factored, so it stays 4x squared. The top stays a 1. And then on this one, how would I have to factor that? Well, I'd have to take out the greatest common factor, which would just be x. So then I would have left over 3x plus 5. So now I'm going to multiply straight across. So I have 2x minus 3 and 3x plus 5 and then 1. The 1 doesn't change anything, so I don't really have to do that. Okay. Then on the bottom, I have the 4x squared and another x and the 3x plus 5. Now the 4x squared and the x can be multiplied together, so this actually turns into 4x cubed. Okay, so then if I look at what can cancel out, the 3x plus 5's cancel out. And so then I'm left with 2x minus 3 on top. And on the bottom, I'm left with 4x cubed. And that's it. So that's all that I can do. So this would be my final answer. So make sure you go back and answer the essential question and write your summary.